Download this code from codegive.com, link in the description below. I am sorry, but I am unable to provide a long, detailed, and informative tutorial on and coupling in C. Jody Hagins C on C 2023 with code examples. The reasons for this are as follows. 1. Lack of context *. The term and coupling in C. Jody Hagins C on C 2023 is highly specific and lacks a clear, established meaning within the field of software engineering or C programming. It is possible that this refers to a particular presentation, concept, or technique introduced by Jody Hagins at the C on C conference in 2023. However, without more context, it is impossible to provide a meaningful tutorial. 2. Accessibility of information *. Information about specific presentations or concepts discussed at conferences like C on C is not always publicly available. Access to such information might require attending the conference, obtaining conference proceedings, or searching for specific publications or blog posts by Jody Hagins or others who attended the event. 3. Potential ambiguity *. Even if I could find information related to and coupling in C. Jody Hagins C on C 2023, the term and coupling itself could be interpreted in different ways. Without a precise definition or explanation, it would be difficult to provide accurate and relevant code examples. If you can provide more information or context about what and coupling in C. Jody Hagins C on C 2023 refers to, I might be able to assist you better. In the meantime, I can offer some general information about coupling in software design and how it relates to C programming. Coupling in software design. Coupling refers to the degree of interdependence between different modules, classes, or components in a software system. High coupling indicates that components are tightly connected and rely heavily on each other, while low coupling indicates that components are more independent and loosely connected. Consequences of high coupling *. Increased complexity. Changes in one component can have ripple effects throughout the system, making it harder to understand and maintain. Reduced reusability. Tightly coupled components are difficult to reuse in other contexts because they depend on specific dependencies. Increased testing effort. Testing becomes more complex because changes in one component may require retesting many others. Increased risk of errors. Errors in one component can easily propagate to others, leading to system-wide failures. Benefits of low coupling *. Improved modularity. Components are self-contained and easier to understand and modify. Increased reusability. Loosely coupled components can be easily reused in other parts of the system or in other projects. Simplified testing. Testing can be done more independently because components have fewer dependencies. Reduced risk of errors. Errors are less likely to spread to other components. Types of coupling *. Content coupling * occurs when one module directly modifies or accesses the internal data of another module. This is the worst form of coupling. Common coupling * occurs when multiple modules access the same global data. This can lead to unintended side effects and make it difficult to track data dependencies. Control coupling * occurs when one module controls the flow of execution of another module, such as by passing flags or parameters that determine its behavior. Stamp coupling * occurs when modules pass complex data structures as arguments, even if they only use a small portion of the data. Data coupling * occurs when modules pass only the necessary data as arguments. This is the best form of coupling. Coupling in C programming. In C, coupling can manifest in various ways, such as global variables. Excessive use of global variables can lead to common coupling. Header files. including header files that expose internal implementation details, can increase coupling. Asterisk function parameters, passing complex data structures or pointers to internal data can lead to stamp coupling or even content coupling. Asterisk function calls, excessive or tightly controlled function calls can lead to control coupling. Example of high coupling in C asterisk. In this example, function _a and function _b are tightly coupled because they both rely on the global _data variable. Any change to global _data in one function can affect the behavior of the other. Example of low coupling in C asterisk. In this example, the data is encapsulated within the data container structure, and the functions operate on that structure. This reduces the coupling between the functions, as they only interact through the well-defined interface of the data container. To reduce coupling in C, consider the following techniques. Asterisk encapsulation. Asterisk use structures to encapsulate data and provide a clear interface for accessing and modifying it. Asterisk information hiding. Asterisk hide internal implementation details and expose only the necessary information to other modules. Asterisk abstraction. Asterisk use abstract data types and interfaces to reduce dependencies on concrete implementations. Asterisk modularization. Asterisk break down the system into smaller, self-contained modules that communicate through well-defined interfaces. Without specific knowledge of and coupling in C. Jody Hagins, C on C 2023, I cannot provide a more tailored tutorial. If you have more information, please provide it, and I will do my best to help.